In this video, we're going to talk about how to calculate the amount of energy or heat that is released or absorbed in a chemical reaction. This is your learning target. Now, previously, remember, we talked about endothermic and exothermic reactions, and that's exactly what we're going back into right now. We learned that exothermic means that heat or energy is released, and endothermic means that heat or energy is absorbed. And we talked about the change in enthalpy. Do you guys remember that? Enthalpy is also known as delta H. You guys can look back at your endo and exothermic notes that we did in the beginning of this unit. And it can be written as part of the chemical reaction, or it can be written separately, like delta H is positive 543 kilojoules, or delta H is equal to negative 300 kilojoules. So it is written as a product when heat is released, or it's exothermic, and it's written as a reactant when heat is absorbed, or endothermic. It can be represented separately using a positive or negative value. That's what I was talking about earlier. And if energy is absorbed or gained, remember that it's positive. It's endothermic. When energy is lost or released, then the delta H will be negative. So these are 4 examples here. Can you figure out which ones are exo or endo based on where the heat or energy value is? So if we take a look at the first one, we notice that 81.6 kilojoules is written as a reactant, right? And so if it's written, if the energy is part of the reactants, that means that energy is absorbed in the reaction, and so we have an endothermic reaction. Whereas the second example, the energy is written on or as part of the product, and so we have an exothermic reaction. Well, if we take a look at the next reaction, delta H enthalpy is written separately. Okay, so it says delta H is equal to positive 37.1 kilojoules. Do you guys remember what delta H, when delta H is positive, what that represents? Right, that represents endothermic. And the next one you see, delta H is equal to negative 100.18 kilojoules, which tells us that it is an exothermic reaction. So let's take a look at this problem. Find the change in heat for the production of 17.1 grams of iron 3 oxide according to the following reaction. So what this is telling us is that 4 moles, well, first of all, if you take a look at the energy, we see that it's written as part of the product, right? So what does that tell us about our reaction? That is it is an exothermic reaction. And what does exothermic mean? That heat is being released. Okay, so this is saying that 4 moles of iron 2 oxide releases 560.4 kilojoules. 1 mole of oxygen releases 560.4 kilojoules, and 2 moles of iron 3 oxide releases 560.4 kilojoules. So in this case, we're focusing on 17.1 grams of iron 3 oxide, and so that's where we're going to start in our fence. Now, this is a little bit different from the stoichiometry that we were doing before, where I was using that picture, the grams of A to moles of A to moles of B, etc. We are going from the mass of a substance to the energy to see how much energy is being released for this particular substance, right? So we are going to start with 17.1 grams of iron 3 oxide, and we're going to copy that unit down, grams of iron 3 oxide. And what do you think is going to go on top? Well, remember, there's only one thing that can go on top, one thing that is equal to grams of a substance, and that's moles of the same substance. So if you look at this setup, what does that look like? It's a molar mass, right? So we have 1 mole is equal to 159.70 grams of iron 3 oxide. So let's continue. We can go ahead and bring down the unit, moles of iron 3 oxide. And we are going to look at the amount of energy that's released. Okay, so if you take a look, how many moles of iron 3 oxide releases 560.4 kilojoules? 2 moles. So we have 2 moles of iron 3 oxide that releases 560.4 kilojoules. Now notice that I put a negative number in there, again, because if I were to write this separately, delta H is equal to negative 560.4, meaning that energy is being released. Okay, so our like units cancel out, multiply, divide, and we get a total of negative 30.0 kilojoules. So that means that 30.0 kilojoules is being released for 17.1 grams of iron 3 oxide. So go ahead and try the next problem on your own. How much energy is transferred when 80 grams of magnesium hydroxide are reacted in the following reaction? Now notice that this enthalpy value is given to you separately, right? It's not part of the reaction, so it tells you that enthalpy value is positive, so that means that energy is being absorbed. So go and set that up, pause the video, because the next thing I'm going to talk about is the answer. And we have 50.9 kilojoules that's being absorbed. So you notice on this slide and the last slide, I put down 2 answers. You guys can write down either one. You can say positive 50.9 kilojoules, and that also means that it's 50.9 kilojoules that's being absorbed, okay? And yes, you must write that positive value in there. And that's it for thermochemical equations.